let's get started. I want to try to make a video for class 10, which is in about an hour. And I want to try to work out through some of the things I want to do today. So we're doing linkage position analysis and using numerical solutions. That's the focus. So I'm going to start off in this video. I'm going to do the Excel position analysis using a solve utility. It's kind of a neat thing. I think it kind of is a good introduction into the idea of the numerical solver. So what we're going to do is we're going to create this same Excel spreadsheet. So we're going to replicate it. So I have these in the notes. You can follow along. I've made this before. I've made a video for it, so that's probably already in there. But I'm going to be repetitious. It happens. All right. So here's the one that already works. I think maybe in the here, did I give you the Excel thing? I don't think I did. Sometimes I would have, I don't know if I actually even made an assignment for it last year. So let me double check. Here's last year's thing right here. Right, okay, so here's last year. And homework assignments, did I ever make a Excel thing here? Here's the one I think that you've just made. It's the draft version of this homework, and then all of a sudden COVID hit and everything fell apart. Yeah, you can see this one's like due class 21, right? So there was a whole lot of gap in terms of assignments and that kind of thing. So things got kind of messed up. So anyway, let's go back to this, and I will do it by way of here. I don't think I gave a core thing, so I don't know if perhaps I want to do this all the way out. See, I don't know if I gave out a template is what I was trying to say. Linkage analysis. I'll make it too long in class analysis. Yeah, this will be too long. So parameter R1 equals, yeah, if I were to do this in class, I think this would take too long. And in terms of my R4, this was like a guided thing in the previous year. All right, we had a we had computers in that lab, so everybody was able to like follow along with certain things. So in some classes, that's what I did, and some of this was trying to show people how to get the thing formatted, right? So I don't know if I want to spend our time doing that. So let me just take this and as if it's formatted right there. Let's pretend this thing is formatted right there. Okay, and let's just get rid of all these values right here and show what we're going to do. All right, so this is all, we'll pretend this is all like blank right in there. And so what I'll do with this right here is I will crush it down and put it over to the side so we can follow along. Maybe, let's see, boom, right there, right? So you can see the thing side by side. Oops, I need to make this thing smaller. This is turning into a great video. That's a great one. And I don't even need to actually make this video, do I? Because I have one that exists already. Oh, come on. Don't do that to me. And then, oh, I see what I just did. Nope. Oh, where did I go? I disappeared. Where am I? Oh, there I am. Okay, so we're back in this, and I gave a value of 10, 3, 12, and 8 in here. And then I said, okay, so this is going to be, what's that, 2, what is it? What is 2 times pi divided by 3, right? And I guess that, what was I doing here? I was trying to make it so an input angle of 120 degrees. That's why I did that. So 120 degrees, then here's my suggested angles, and then right in here, just so I could see the thing. I went in degrees next to it. And we could do that, right? So the units, nobody cared about the units. Boom, inches. Oh, why did I do that? Inches, and then inches. Okay, and then for the upper leg, I said, okay, so this is going to be 0, 0, and then I said equals, and I just took my B5 right here, that times the cosine of B10 right there, right? So there. Okay, so that's all right. So I'm just plotting this out right here, right? So it's going to be equal to that times the sine of this one right here. Okay, so that's going to plot out those points, and then here. Okay, that makes sense. I'm going to have this one, right, plus that one times the cosine of this right here, right? Is it true? Yep, okay. And I can make the same thing here, so I'm going to say this is going to be the y value plus the sine of this right here too, right? Boom. I think that's going to be right. And then what I do right here is I'm going to set this one equal to B4, right? So here's the x value. No, this one right here, right there. So there's the x value, and then I can just set this equal to 0 right here, because this is the ground link. It's the horizontal, the ground position of the right here, and so this is going to be equal to this plus B7 that times the cosine of that, I believe. Boom. And then this similarly is going to be equal to that, but of course it's going to be 0, plus the this guy times the sine of that. Boom. And I think I have all of that done. And now for the difference, I'm going to say G6 minus G10, which is that that's the G6. All right, so G6. Oh, I see. It's going to be the difference in each of them. So it's going to be this. It's going to be this minus that. Boom. And then this is going to be this minus that. I think I hit the wrong one. Yes, I did. It needs to be that, right? So 3 and 3 are supposed to be the same number. So now what I could do is I could just take the square root of this squared plus squared plus this squared. We're going to see the relevance of this in a bit. So we take that, and what's going to be helpful to us is if we plot this thing out. So I think I'm just going to plot it out like this thing. And I don't know why it's saying it's residual. I guess it was because it was trying to plot this out. Okay, so that's going to be meaningless right there. Okay, so I just screwed that whole thing up. Let me say, I think what I did was to plot, I think I said insert plot like that right there. All right, so that's going to be this first leg, and then I'm going to select some more data and add in another. So I'm going to add in another word. Here's the x and y. Oh, these are the x's, and here's the y's. All right, so I can add some names to it later right here. So what I want to do is I want to go to my solver. So if you don't already have it in here, we go into options, and then we go into add-ins, go to Excel add-ins. We're going to manage, so we go and manage them, and we add in, we click in solver. I said okay. So under data it shows up as this guy right there, right? So when I click on him, it's got a new field right here, and I want to set an objective. I want to hit that a residual, and I would like to make it a minimum. And I'd like to do it by changing these two cells. So it's going to change those until it gets there. And now there's other things that we can choose, by the way, in terms of the type of selector method. And there's other things that we could do. There's a lot more things that I'm not familiar with, but it would be interesting to mess around with these. But we can hit this solve. And I think I might have hit the wrong thing. But you could see that that's the solution. So I might have set this thing up the wrong way. Yeah, I think I did. So what did I do wrong? That's the question. That's plotting and that's plotting. But what I should see here, so I got that one right, is that this one is wrong. What I have is I have that as 12. Yeah, so I'm ending up with something weird right here. Yeah, what is that? That's supposed to be sine. Oh, I forgot to do. There you go. That's where I forgot to do. I needed to multiply him by a distance. So I think that's going to be that distance right there. We need to multiply. Boom. All right, so let's do our solver again. I need to solve, and I think I could do all the things right things. There you go. So that's the solution. And we could also try some other things out right here. So we could also try it out with -1. So let's try it without, here's starting off in a different location, -1.5. And now we go to our solver and try it out. Oh, no, it messed with me. So what I think I have to do as part of this, I'll try -1 again and -1.5. Right, is try, yeah, it figured out how to do it. Let's see, -1 and -1.5. I'll try a different one, maybe -2. Boom. All right, so maybe now it's going to get closer. I'm going to try this. No, it's doing this. Solver cannot find a point for which all the constraints are satisfied. All right. Let me try this again. I want to change that, and I want to minimize it. I'm going to set it to a minimum by changing these two variables. Okay, make unconstrained variables non-negative. Let's see if that does the thing. There you go. So we found a solution right there. So that was a little box. So I'll try to remember that during our class right in there. But this was a simplified numeric solution. It just messed around with these things until I found a convergence. But one of the important things that we note here is the initial guess mattered. That's what I'm trying to get at here. And it just messes around with it numerically. So let's see what one of the possible methods we could do. We could try these other things right here. You could try with, once again, we have a -1 and a -1.5. We could try these solver again, but try it with a different solve right here. And it says it wasn't able to do it. Right, so it didn't like that. That solver didn't work with it. Evolutionary, I don't even know what those are. But try to solve. Nope, it couldn't do it. But it could do this other one, right? So we want to go back to our GRG nonlinear. I might even want to look up what that is. What is a GRG nonlinear solver? What is that compared to this other? And it's supposed to be a solver. Anyway, I'll end the video and because I'm being distracted anyway. So there we go, 15 minutes. hopefully eat up some class time. Yeah.